Have you ever wondered why objects could float in a body of water, like ships or fish? This is Cassidy,
Martin, and
Brand.
and today we will be talking to you about buoyancy. Buoyancy is the ability or tendency for an object to float in water, and it is the force equal but opposite to gravity as it is submerged in the fluid.
this concept is useful in the building of ships so they don't sink. This picture shows how the forces are acting on the ship, that is, gravity and buoyancy. We will be performing an experiment that shows this in action. We will conduct 3 trials, one with a quarter, one with a ping pong ball, and lastly with a popsicle stick.
For this part of the experiment, we are using a quarter. If you look at the drawing, you can see that there's a force acting down and a force acting up on the quarter. When we take the heights of the quarter, H1 is the depth from the top of the water to the top of the quarter, and H2 is the depth from the top of the water to the bottom of the quarter. We then multiply the density, the gravity constant, and the area of the quarter to find both F1 and F2. Once we found those values, we plug them into the FB equation to find the buoyant force. Then, we found the force of gravity using the FG equation. Our buoyant force of the quarter was close to 0, which makes it less than the force of gravity. That led us to predict that the quarter will sink.
For this part of the experiment, we are using a ping pong ball. If you look at the figure, you can see that there's a force acting down and a force acting up on the ping pong ball. Then we obtain both H2 and H1, which is the top of the ping pong ball, which is above water, so that means H1 is 0. Next, we then multiply the density, the gravity constant, and the area of the ping pong ball to find both F1 and F2. Once we find those values, we plug them into the FB equation and find the buoyant force. Then we find the force of gravity using the FG equation. A buoyant force of the ping pong ball was greater than the force of gravity. That leads us to predict that the ping pong ball will float.
In this part of our experiment, we're testing the buoyancy of a popsicle stick. Looking at the figure, we can see that H1 and H2 are barely above and below the waterline. After measuring the heights and multiplying the density, gravity constant, and the area of the popsicle stick to find F1 and F2, we will then plug these values into the buoyancy force equation to find the force. We will compare the buoyancy force to the force of gravity to determine whether the popsicle stick will float or sink. We believe the popsicle stick will float based off its low mass and density. That concludes this experiment. Hopefully this video provided you with a better understanding of the concept of buoyancy. Thanks for watching.